up guys, welcome back to a brand new academic learning video, and in this video we are going to be talking about radicals. Alright, let's get started. Okay, so first of all, let's just do a quick review of what radicals are. So say we have something like the square root of 4. Now this is just a new operation. This is not something I'm inventing or anything, or technically it is something I'm just inventing. This is just a tool. This isn't a new concept or anything. If you have the square root of 4, then what we're basically saying here is we're asking what number, when I square it, equals 4. So that is going to be 2. Let's do another example. Let's say we have the square root of 16. Now this is asking what number, when I square it, equals 16. And that is 4. Now there's also other roots, like the cube root of things, and that asks what number, when I cube it, will be equal to the inside number. But for the purposes of this video, we're not going to be going over it. But just keep in mind that all of the properties that I'm going to mention in this video also work with cube roots and fourth roots and stuff. Alright, so let's generalize this pattern for the square roots. So basically, we're saying that the square root of x is going to be a number, y. And this y has a property such that if we square that number, it's going to be equal to x. Okay. Now, let's see. Now, you can already kind of see the connection between radicals and exponents, but let me try to convince you that radicals and exponents are actually the exact same thing. So, let's say we have x to the 1/2 power. Now, a lot of times in math, if you don't know a value to something, you just call it a variable and just move on. Okay, now let's see if we can simplify this. Well, one thing we could do is square both sides. So on the right-hand side, we get y squared, which is just, well, y squared. And on the left-hand side, we can use our exponent properties. X to the 1/2 squared is going to be equal to x to the 1/2 times 2, which is just x to the first. And anything to the first power is just itself. So we're saying that x is a number that is equal to y squared. Now already, this might be familiar with the definition from the square root we saw a couple of seconds ago. But let's go a bit further. Now let's take the square root of both sides. So the square root of x is equal to, and if we square a number, then take the square root. Like if we have 2 squared and we take the square root, what this is asking is what number squared gives us 2 squared, and that's just 2. So what number squared that will give us y squared is just y. So the square root of x equals y, but from this first line, we know that y is equal to x to the 1/2. So we say that the square root of x equals x to the 1/2. Now this is very, incredible, because we learned 2 things from this. One, we learned how to convert exponents to radicals and vice versa. But 2, we also learned how to use exponents to fractions. Now, before, when we had an exponent, it was raised to a whole number. So like 2 cubed. But now we can do 2 to the 3 over 1, 2 to the 3 over 2, as long as we convert this to a fraction. Even like 2 to the pi we could do. And if you're wondering how we could do 2 to the 3 over 2, because this is 1 over 2, well, what you would do is split this up into 2 to the first power times 2 to the 1/2. And by our exponent rules, these 2 add to 3/2. And then you get 2 times the square root of 2. But that's not really important for this video. Okay. And again, this is not just square roots. If we have something like x to the 1/3, by the same pattern we used before, that's the cube root of x to the 1/4 is the fourth root of x, and so on. Okay, so now we know there's exponent properties, and we know that exponents are radicals. So therefore, we can use the exponent properties for radicals. So let me give you an example. Let's say we have the square root of x over y. Well, if we take the square root of something, that's just raising it to the 1/2 power. And now we can use our exponent properties. If we have x over y to the 1/2 power, that's x to the 1/2 power, over y to the 1/2 power. And now here, 1/2, that's just the square root, so that's square root of x over square root of y. So we've just proved a new radical property. Square root of x over y is the square root of x over the square root of y. And there are tons of these radical properties just correlating with their corresponding exponent properties, and I encourage you to try them. But for the sake of time, there's mainly just one radical property that's very important, and that is, if we have the square root of x times y, that's equal to the square root of x times the square root of y. Now the proof for this is pretty simple. Convert square roots to exponents, so xy to the 1/2, that's equal to x to the 1/2 times y to the 1/2 by our exponent properties. And now just convert to square roots and you get this. Okay, now you may not realize why this is so important. But here, if I give you a number such like, I don't know, square root of 72. Now, how would you simplify this? Well, you can't really simplify this because it's not a perfect square. You can't take the square root of this 72. But actually, there is a way to simplify this. And one way you can simplify this is by doing the square root of 36 times 2. 7 is just 36 times 2. And now we can split this up into the square root of 36 times the square root of 2. From this rule above, and we get 6 times square root of 2. And this is very important. Now, instead of just relying on the square root of 72, which is a very, unimaginable number, now we can just take the square root of 2 and multiply it by 6. And the square root of 2 is a much more manageable number. So that's how you can simplify radicals. But let's find a more efficient method of simplifying radicals. So let's come up with the process. So step 1 is to get your radical. Get your radical. So let's say our radical is, I'm not sure, maybe square root of 24. Now step 2 is to see if there are any perfect square factors. See if there are perfect square factors. And now the reason we're so concerned about perfect square factors is because if we split this up into the square root of 8 times the square root of 3, this isn't really simplified because we're just left with more radicals. But if we split this up into the square root of 4 times the square root of 6, or sorry, not square root of 2, square root of 4, because this is a perfect square, we can simplify it. So that's why we're worried about perfect square factors. And then step 3 is to combine and simplify. So for this example, one perfect square factor would be, 4. So we can split this up into the square root of 4 times the square root of 6, which is equal to 2 root 6. Okay, now let's do one more example, or a couple more. How about we do the square root of 48? Now here, this is equal to the square root of 4 times the square root of 12. So this is equal to 2 times square root of 12. But careful, we're not over here. Because if we look at the square root of 12, we can split that up into the square root of 4 times the square root of 3. And we can simplify that even further to 2 times square root of 3. Or 4 times root 3. And for root 3, we can't split it up into any perfect square factors. So this is actually kind of fun. Let's do another one. Let's do the square root of 32. Or actually, no, let me do the square root of, yeah, okay, 32. 32 is good. So this is equal to the square root of 2 times the square root of 16. And the square root of 16 is 4. And the square root of 2 is 2. And check, can the square root of 2 be reduced to some perfect square factors? Well, no. I mean, technically it can be reduced to the square root of 1 times square root of 2, but square root of 1, that's just going to be equal to 1, so it won't simplify this further. Okay, so that's how you can simplify radicals, and just to recap of this video, we learned how to simplify radicals, we learned fractional exponents, and we learned some radical properties. Okay, so if you have any questions for this video, please email me, leave it in the description. It's going to be about it for this video, and I'll see you next week.